Hello guys, this is my tutorial on how to tram up your machine and have everything squared up as it should be. This is a dial indicator and this is a dial test indicator. With the dial indicator, what you're doing is measuring the displacement of this needle. With the dial test indicator, however, the numbers actually doesn't represent anything because the movement of that needle is like an arc. With dial indicator, you usually get about 10 millimeter of displacement, but you can find 25 or even higher ones. Dial test indicator, however, is a bit on the short side. However, the accuracy and the resolution of the test indicator is much higher than what you get with a dial indicator. It would be nice to have both of these. Now, if you're a beginner, I would recommend you getting a dial indicator because first of all, you can use these to tram and square up your machine. And also you can, because the numbers actually represent an actual real world measurement, you can use this to measure height and thickness of a part by making a jig for it. Dial test indicators are more accurate, and especially for applications like squaring up your vise, they are easier to use. Now that we know how to use a dial indicator, we're first going to start with the z-axis. On your z-axis you have the spindle and your rails and your column. There's this common mistake that everyone does that they do, and that is they tram their spindle to their table without checking anything else. Now there's a lot of problem with that. First of all, your XY table is extrusion. You don't know whether it's flat or not. Second, your spindle might not be parallel to your z-axis. Now imagine this. You have your drill and you have your stock. You might be perpendicular to it, but is your axis of movement in Z perpendicular to that drill? Like, you could come like this, right? This is why it's important to know whether your spindle is parallel to your Z rails. Now to check that, you need to first measure from this side, then from this side. Okay, so you go ahead and put your dial indicator on your spindle perpendicular to the x-axis. Now there's a tip that you can use with these cheap dial indicators. When you first set them, they don't quite sit where they should be. So you can just wiggle your machine a bit and it's now where it should be. Then you go ahead and zero the dial indicator. After you install your dial indicator, you want to move the z-axis up and down. As you just saw, the dial indicator didn't really move at all. Now this could mean that your spindle is parallel to your z-rails, or that your magnetic base is actually flexing. To compensate for the flexion, you can just wiggle your machine again. After we did this side, we go ahead and probe from this side. Now that you know that the z-axis is parallel to your spindle, we can start to tram our machine. Tramming is basically whether your spindle is perpendicular to your XY movement. Now the key point is I talked about movement and not table. This is aluminum extrusion and it's not flat. That's why at first we need to check whether our table is flat or not. To tram your spindle and check whether the XY table is flat enough, you can use one of these. The idea is that you put your dial indicator on one of these, okay, then you mount the other end to your spindle. Now that we have installed this tool, we can go ahead and see the flatness on our X and Y axes. First, I'm going to start with the Y axis. Now another trick for using the dial indicator, especially with this tool, is because this is made out of plastic, it flexes a lot. One thing you can do is grab the top of the dial indicator and just drop it a couple of times until you make sure that it is staying at 0. The goal is to have a repeatable measurement. First I'm going to probe the closer side, then I'm going to gradually go ahead and probe the back side. As you just saw, I have about 200 micron of difference in this whole table. 200 microns is a big number. That's why you might want to use a piece of glass. Now, as you saw, even with the glass, we had a 200 micron difference between these two sides. However, it was more of a gradual climb. So what I'm going to do is use some sort of paper to raise this side a bit up and have a glass that is flat and perpendicular to the XY movement. Now, as you just saw, my table is very crooked, and what I need to do is to have a baseboard that I machine the top surface with this spindle. After that, I can tram my mill. However, most of you guys, especially the guys that buy the LDO kit, will probably have a flat enough surface that they can use to tram up their spindle. That's why I'm going to continue explaining how you need to tram your spindle. Imagine that these two sides read the same reading. Okay, what you need to do is to have your spindle at the center of your table. You might want to use something more rigid than this one. Anyways, now that you've zeroed out your dial indicator, you need to move the dial indicator to the front and back by the spindle itself. Now for the x-axis, you need to do the same thing. First, check your plane, then tram up your spindle. Take some readings. Now, as you just saw, my x-axis is not that crooked, so I might just get away with it. Now, according to what you read on the dial indicator, you might want to go ahead and untighten these 4 bolts. This way your z-axis becomes free. Then what you can do is tilt your z-axis front to back or even side to side to compensate any misalignments. Now, if you want to have a machine that just works, it is reliable and it's accurate, you need to take all of these steps seriously. Now, the goal was to show beginners how to tram and set up their machines. I might have missed something. Let me know in the comments. Also, I will be having another video coming up about the Milo V1.5 and how to assemble the X and Y assembly without taking the carriers off of the rails. If you have any problem or question, you can ask in the Millennium Machines Discord. Have a good day, make some chips.